Hello out there, welcome to this tutorial on sequences and series. In this video, we'll be looking at arithmetic progressions. In our next video, we'll be looking at geometric progressions. Check the description section of this video on our YouTube channel to get links to other videos on sequences and series. Consider the following: A, 3, 8, 13, 18 and so on. B, 26, 19, 12, 5, -2, -9 and so on. These are infinite sequences since the list is endless, so it does not have an end, so we call them infinite sequences. Can you list the next three terms in A and B above? Is it possible we list them? For any sequence, there is a rule for the generation of the terms. That rule is called the formula, and we have to study this first to see what the rule is in order to enable us get the next three terms. So from A, we have a 3, 8, 13 and 18. If you look at it, 3 plus 5 gives 8. Will 8 plus 5 also give us 13? Yes, and also 13 plus 5 gives 18. Therefore, to get the next term, 18 plus 5 will give 23. 23 plus 5 gives 28. 28 plus 5 gives 33 and so on. Then also for B, we have 26, 19, 12, 5, -2, -9 and so on. Now to get the next three terms, we have to study and get the rule again. Here 26 and 19. Can we say 26 minus 7? Yeah, it gives 19. 19 minus 7 gives 12. 12 minus 7 gives 5. 5 minus 7 gives -2 and so on. Therefore, to get the next term here, we say -9 plus -7, we gives -16. -16 plus -7 gives -23. -23 plus -7 gives -30 and so on. So we have gotten the next three terms of the two sequences. The sequences above are arithmetic progressions, and in short we call it AP. In each case, any term of the sequences is defined as Tn equal to A plus n minus 1D. This is representing the term. Depending on the course material you are using, it could be U, it could be A, and here we are using Tn to represent any of the terms of the sequences, where n is the number of the term, A is the first term, and D is the common difference. And like we can see in A, we have the first term to be A. The common difference there is 5, because we have added 5 to every term to get the next term. So from here we go to solve some examples. So example 1, given that -5, -2, 1 and so on is an AP, find A, 10th term, B, 73rd term, C, nth term of the sequence. Now we go ahead to get what we are given. As in our formula, we are given A to be -5 and D to be 3. How do we get D? We should note that D is T2 minus T1, that is second term minus first term, or third term minus second term, or fourth term minus third term. In any of these, you will get the common difference. So we now get to A. We remember our formula Tn equal to a plus n minus 1d. For a, we are looking for 10th term, so we are looking for T10. So T10, our a is -5 and our n is 10. That will be plus 10 minus 1 multiplied by 3, since our d is 3. So we start from the brackets. We have -5 plus 9 times 3. So we start with the multiplication. 9 times 3 gives 27. So we have -5 plus 27, and that gives 22. So we go to B part of the problem, which is T73. For T73, we still have our a to be -5 plus 73 minus 1 multiplied by 3. Then we go again, -5 plus 72 times 3. 72 times 3 will give us 216, and -5 plus 216 gives 211. So we go to C. For C, we are looking for nth term. To get the nth term of this sequence, it is to get the general formula for this particular sequence, such that if you substitute in any of the values of n, it gives you the term for the sequence. So here we go. We know our a is -5. We don't know n, so plus n minus 1. Then our d is 3. We put our 3 there. So I will now expand this. If we are expanding this, we have -5 plus 3n minus 3. Here we collect the like terms. That's -5 minus 3 plus 3n. That will give us 3n minus 8. This is the nth term of the sequence. So that if you are looking for the 10th term now, you just put n is equal to 10. You have 30 minus 8, which is 22. That was the 22 we got in the solution of A. So that is the end of solution to example 1. We go to example 2. For examples 2, how many terms are there in each of the sequences below? We need to verify they are AP. How do we do that? This is 13 minus 7, which gives 6. 13 plus 6 gives 19. 19 plus 6, 25, and so on, up to the last term. These are examples of finite sequences because you know the first term and you know the last term. So we will now look at how many terms do we have in each of the sequences. We have verified the first one to be an AP. So starting from the solution of A, we know this formula L is a plus n minus 1d. Be informed that we have Tn, and we told you that Tn is for any term. So since we are given the last term, so we are going to be using this formula to get the number of terms in the sequence. So we start from A. We need to bring out everything we have in the formula from the question. So we have a to be equal to 7, and our d is equal to 6. We have told you initially that 13 minus 7 gives 6, or 19 minus 13 gives 6, and so on. And here our last term is 103. Substituting all this in the formula, we'll be able to get the value of n, such that we have 103 is equal to 7 plus n minus 1, then multiplied by d, which is 6. To simplify this, I maintain this, which is n minus 1 into 6. Then taking this to this side, it becomes 103 minus 7. That will give us 96. Then dividing both sides now by 6, I will have n minus 1 is equal to 16. Since 96 divided by 6 gives 16, then you now take this to the right hand side, which gives n to be equal to 17. So with this, the sequence in A here is an arithmetic progression and it has 17 terms. So from here we go to B. For B we have 71, 63, 55 up till negative 1. The last term here is negative 1 and our first term is 71, and our D, which is the common difference, is negative 8. Since 71 minus 8 gives 63, 63 minus 8 gives 55, and here our last term is negative 1. So substituting in these parameters in the formula, we have negative 1 equal to 71 plus n minus 1 multiplied by negative 8. I love putting my negative values in brackets to avoid any form of confusion. So I'm returning this to this side, which is n minus 1 into negative 8. Then this is coming here, which will give me negative 72. Now dividing both sides by the negative 8 here, I have n minus 1 is equal to 9. And taking this negative to the right hand side, n is equal to 10, which means the sequence in example 2b has 10 terms and it is an arithmetic progression. So we go to C part of the problem. For C, I have the first term to be negative 9. To get D, we say negative 12 minus negative 9, and that will give us negative 3. So D is negative 3, and our L, which is the last term, is negative 87. So substituting all these in the formula, we have a negative 87 is equal to negative 9 plus n minus 1 multiplied by negative 3. So again, I bring in the negative 3 to the left hand side. Now for the constant term here, I'm taking this to this side. It will be negative 87 plus 9, and that will give us negative 78. So dividing both sides by the negative 3 here, we have n minus 1 equal to 26. Taking this negative to the right hand side, n is equal to 27, which means the sequence in example 2c has 27 terms. And that's the end of solution to example 2. We go to example 3. For example 3, the first and 9th terms of an AP are respectively 6 and 78. Find its common difference. Okay, so we are given the first term to be 6. We don't know the common difference. And also we are given the 9th term to be 78. So if we substitute into this formula, our 9th term is 78 is equal to 6, which is the first term, then plus 9 minus 1, then multiply by D. So we have 78 equal to 6 plus 8D. Bringing this to the side, 8D is equal to 72. And D is equal to 9 after dividing 72 by 8. So for example 3, the common difference of the sequence represented there is 9. So we go to example 4. Example 4, an AP has a common difference of negative 7 and its first and last terms are 18 and negative 80 respectively. How many terms are there in the sequence? its first and last term. Okay, we are still using the formula L equal to A plus N minus 1D, so that our common difference is given to be negative 7. Our first term, which is A, is 18 and L is negative 80. Substituting all this into this formula, we have negative 80 is equal to 18 plus N minus 1 multiplied by negative 7. I'm going to use a different way. I want to expand this. The other time I took this to the side and divide. Now let me give us another way. Probably you may like that. I still maintain negative 80 is equal to 18 negative 7 times n. I'm expanding. That will give us negative 7n. Negative 1 times negative 7 will give us positive 7. Then I take this plus this. That will give us negative 80 plus 25. Because 18 plus 7 gives 25 minus 7n. So this is negative 7n. I'm bringing it to the left hand side. It becomes 7n. I'm taking negative 80 to the right hand side, which is going to be 25 plus 80, which gives 105. Dividing both sides by 7, n is equal to 15. Therefore, the sequence has 15 terms. So we are done with this, and we go to example 5. For example 5, the 6th and 11th terms of an AP are 40 and 75 respectively. Calculate the 30th term. From our formula, Tn equal to A plus N minus 1D. So let's look at what we are given in the problem. We are given T6, which is equal to 40. And remember, for an AP, the general formula for T6, that is term 6, is A plus 5D. Because A 6 minus 1 is 5D. So we have it as A plus 5D. And we are given the 11th term to be 75. So we have T11 is equal to 75. And the formula for T11 is A plus 10D. So with this, we can solve this simultaneously to get the values of A and D. So we call this one equation 1 and call this equation 2. If we go by elimination method, we can easily eliminate A. To do that, we subtract equation 1 from 2, so that 75 minus 40 gives 35. A minus A will give us 0. Then 10D minus 5D will give us 5D. So that D is equal to 7 after dividing both sides by 5. So we can now go ahead to find the value of A, which is the first term from any of the equations. So we put D equal to 7 in equation 1, so that we have 40 equal to A plus 35. Since 5 times 7 gives 35, so that A is equal to 40 minus 35, and that gives us A equal to 5. So we can go ahead to calculate the 30th term. That is T30 is equal to A. Our A is 5. That's going to be plus 29 times 7. Since 30 minus 1 gives 29. And that will give us 5 plus 203. 29 times 7 is 203 plus 5 gives 208. And that's the end of solution to example 5. So go ahead to example 6. Example 6. The sum of the third and seventh terms of an AP is 44. If the ninth term is 42, calculate the A, first term, and the common difference. B, 101st term. It's just similar to what we did in example 5. In our solution here, we are told that T3 plus T7 is equal to 44. So we know the formula for T3, which is A plus 2D, then plus the formula for T7 is A plus 6D is equal to 44. This is 2A, 8A, so 2 is common. We can just say A plus 4D. Since A plus A is 2 divided by 2 gives A, and 2D plus 6D is 8D divided by 2 gives 4D, is equal to 22. 44 divided by 2, which is 22. So that gives equation 1. Then the ninth term is 42, which is A plus 8D is equal to 42. Since the formula for T9 is A plus 8D, which gives 42, we call this one equation 2. Again, for A to calculate the first and the common difference, we are going to say equation 2 minus equation 1. A minus A gives 0. 8D minus 4D gives 4D. 42 minus 22 gives 20, and D is equal to 5. We can now go ahead to find A from any of the equations. So we put D equal to 5 in equation 1. So we have A plus 20. 5 times 4 is 20 is equal to 22. So that A is equal to 2. That is 22 minus 20. So from this, we are done with A because we've gotten the first term and the common difference. So we go to B. We are to find 101st term, that is T101, is going to be A, which is 2 plus 100 times 5. Remember, we said the formula for 101st term is A plus 100D. This is our A, which is 200 times D, which is 5. So that's simplifying this. 100 times 5 is 500 plus 2 gives 502, which is the 101st term of the arithmetic progression represented in example 2. And this is the end of this tutorial. I hope you enjoyed it. Please like and share this video. Also remember to subscribe to our YouTube channel if you have not done that. See you in the next video. Till then, goodbye.